Properties of exponents. The first property is the product of powers, which says exponent with the base a and um, exponent of m times a to the exponent of n is equal to a where you add the exponents. So for example, let's say I have 2 to the power of 2 times 2 to the power of 3. That's going to equal 2 to the power of 2 plus 3, which is simply 2 to the 5th power. So you add your exponents when you're multiplying exponents with the same base. Then we have the power of power property, which says if I have a number with an exponent and it's in parentheses with another exponent attached, you simply multiply the two exponents. So kind of like the distribution property, when you multiply everything inside by a number outside, you're essentially going to do that. You're going to distribute the exponent to all exponents inside. So for example, if I have 2 to the second power to the third power, it's going to equal 2 to the power of 2 times 3, which is 2 to the 6th power. If you have multiplication taking place inside parentheses with two different bases, and you have a power on the outside, you just make sure you distribute the power to both bases. So for example, let's say I have 2x on the inside to the power of 2. It would end up being 2 squared x squared. And could you go further? Yes, but I just wanted you to see the gist of how that works. Then we have the quotient of powers property, which says if you're dividing two numbers that have the same base, then you take the exponents and you subtract. So for example, if I have 2 to the power of 3 over divided by 2 to the second power, that's equal to 2 to the power of 3 minus 2. You always put the one on top first. So that means it's 2 to the first power, or just 2. Then you have the power of quotient property, which is similar to the power of product, except for there's division taking place inside, and you just distribute the exponent to all bases. So let's say I have 2 over x to the power of 2. That means it would be 2 to the power of 2 over x to the power of 2. The negative exponent rule simply means anytime you have a negative exponent, you can put a 1 over the number to the positive exponent. So if I have 2 to the negative second power, it's the same thing as 1 over 2 to the positive 2, positive 2 power, or positive second power. Some other exponent rules you should be aware of is any base to the 0 power is 1. Any base. So 2 to the power of 0 is 1. X to the power of 0 is 1. Any base to the power of 0 is 1. And then just some extra information about square roots. Square roots are technically powers. They're fractions. The cube root is also a power. It's the power of 1/3. So basically any root, you put a 1 over that number, and that's your power. So we're going to practice using those rules to simplify these expressions. What I like to do is group like terms. So on the first one, I'm going to group 2 with 3. Then a to the negative second with a to the third. And then I have B all by its lonesome. So when you're simplifying, you got to remember to leave all answers with positive exponents, as well as make sure any fractions you have are in lowest terms. So 2 times 3 is 6. A times a to the negative second times a to the third is the same thing as a to the negative second plus 3. And then again, we have b squared at the end. So that would be 6 times a to the first power, so just a, and then b squared as a final answer. All right, on the next one, it's a division setup. So I know for Q, it's going to be 2 minus 7. Again, the top number always comes first. And then for R, it'll be 4 minus 3. Q would give me a negative 5 for my power, and R would give me 1. So again, you can't leave negative exponents. So remember the negative exponent rule or property says make it the reciprocal with a positive power. So 1 over q to the fifth times r, and r is over 1. So now when you multiply straight across. So you would have r over q to the fifth power. On number 3, you have 3 different bases inside the parentheses and the power of 3 outside. So again, you're going to distribute that power to all bases inside. A already has an exponent, so you're going to multiply its current exponent with 3. B also has its own exponent already, so again, it's going to multiply with 3. So you would have negative 2 to the third power, and then a to the 12th over b to the 6th. You can leave your answer like that and it's fine, or you can go ahead and find negative 2 to the third power. You might want to write that out. That's negative 2 times negative 2 times negative 2, right? So negative 2 times negative 2, positive 4. Positive 4 times negative 2 is a negative 8. So negative 8, a to the 12th over b to the 6th. Now we're going to talk about operations with polynomials. First, you need to make sure you understand what the degree of a polynomial is. And the degree essentially is the largest power for the polynomial. You also need to make sure you write polynomials in standard form. Standard form is when the largest power is first, then followed by the next largest, and so on and so forth until there are no more powers. So anytime you're simplifying expressions, make sure you write your final answer in standard form where, again, the powers are shown in decreasing order. So for number 4, we're going to simplify the expression by adding the two polynomials. Some people choose to add horizontally, or some people choose to stack vertically. Stacking vertically is easier if you need to, if you have trouble staying organized and keeping up with things. So let's apply the stack rule. So line up your like terms. So negative 4x squared is going to line up with 6x squared. Positive 9x lines up with negative 7x. And negative 5 lines up with 8. All right, so I would have, whoa, I wrote to the 6. I'm so sorry. All right, squared. So 6x squared minus plus negative 4 is going to give me a positive 2x squared. Notice the variable stays the same. I'm just combining the numbers in front. I'm not changing the numbers at the end. Now I have negative 7x plus 9x is a plus 2x. Then positive 8 plus negative 5 is a plus 3. So this is my polynomial. It has a degree of 2 because 2 is the largest exponent. Now before I stack the second one, you want to distribute the negative throughout the entire second parenthesis. It's also going to change it to a plus sign. So when I distribute the negative, I'm going to have a negative 2x squared, a negative 3x, and a positive 1. You're distributing negative 1 to all terms. And again, your sign changes from a subtraction sign to a minus sign after you do that. Please make that a habit to do every chance you get when you have a subtraction sign. You must distribute the negative and change it to the plus sign. Now let's combine our like terms. So 4 plus negative 2x is positive 2x squared. Negative 5x plus negative 3x is negative 8x. 6 plus 1 is 7. So this is the simplified version. And again, it's a degree 2 polynomial. So we've added, we've subtracted polynomials. Now we're going to multiply. So to multiply, I recommend using a box to stay organized. The size of the box depends on the number of terms each polynomial has. So for this first one, it's going to be it's going to have 1 row, 3 columns, because I'm going to multiply 3x with 2x squared minus 4x plus 6. Okay? So 3 times 2 is 6. X times x squared is x cubed. Why? Because x has a power of 1 times x to the power of 2, and we just did our exponent rules, means you add the exponents. So it's x to the third. Now, 3 times negative 4 is a negative 12. X times x is x squared. Again, why? Because it's x to the first times x to the first, and you add your exponents, so you have x to the second. 3 times 6 is 18, and then x times 1 is just x. So the solution or the product is 6x cubed minus 12x squared plus 18x. Do you have to use the box? No, but again, it's a way to stay organized. Now on our next problem, the first term or first polynomial has 3 terms. So I'll need 3 rows. All right. However, the second polynomial has 2 terms, so that means I'll need 2 columns. So the first one, I'm doing n squared plus 4n minus 6 down the side, and then n and plus 2 across the top. Can you turn the box the other direction? Yes, you're more than welcome to. So there's not only one way to do the box if you choose to do it. So I'm going to multiply n squared with n, and I would get n cubed, again because n squared times n to the first, you add your exponents. Then 4n times n is 4 plus 4n squared. Negative 6 times n is negative 6n. Again, I love the box because it helps you stay organized. Now let's do the second column. N squared times positive 2 is positive 2n squared. Positive 4n times positive 2 is positive 8n. Then negative 6 times positive 2 is a negative 12. So bring all the results outside of the box. You would have n cubed plus 2n squared plus 4n squared plus 8n minus 6n minus 12. Now, as you can see, I have some like terms that I can combine. I have a plus 2n squared and a plus 4n squared, and notice that there are diagonal across from each other in our box. That usually happens. So when I combine them, I would get 6n squared. Another reason I love the box. It keeps those types of things easily identifiable as well. Then you should also notice I have a plus 8n and a minus 6n. Those are like terms. Again, they were diagonal on the box. And they would give me a plus 2n. Since those are the only other like terms, bring everything else down. So n to the third power, 6 plus 6n to the second power plus 2n minus 12 is the final answered in simplified form. So this concludes your lesson for today. Finish the rest of the problems on your own.